I'm Chris, and I'm a product manager here on our Cloud Dataproc team. And I'm really excited for this presentation because we get to talk about all the cool features that we've come up with since our last Cloud Next. And I even get to do it with two of our rockstar engineers. I got with me Mikayla as well as Karthik. And they've actually built a lot of the features we're about to show you. The way I want to start is just by making sure that everyone knows everything that you're about to see is publicly available. Go out, kick the tires on it. We'd love to hear feedback. You can go use everything we're about to go talk about. Now, I have a ton of things I want to get to, so I'm going to just start to jump in. And quickly, though, before I do the new features, I want to quickly baseline on what Cloud Dataproc is. So Cloud Dataproc, this is Google Cloud Platform's fully managed Apache Spark and Apache Hadoop service. And I'm saying Hadoop and Spark, but it's really an engine for running lots of open source software in that ecosystem. We give you customizable machine types, meaning that you can have a set of machine learning jobs running on one cluster that might be very compute intensive. While at the same time, you have some ad hoc BI applications that are running on a memory intensive cluster. And the two never have to contend for resources, but can still be reading and writing from the same cloud storage data sets. And we also had some customers that create very large customers with us, when they need clusters like this. So, and they can just take them down when they're done. So for instance, our engineers were working with Twitter, and they received a note that was like, hey, are we your largest Dataproc cluster? And we kind of look at each other, we're like, I don't know, what are you talking about? And we get and checked. And they had actually just needed a 90,000 core cluster, and were able to go create that on demand, never getting a hold of the Dataproc team or in about procurement, just went, created a 90,000 core Dataproc cluster, and then tore it down when they were done with it. And so they're able to do this because we have a lot of tools and features that are specifically designed for supporting these kind of architectures and ephemeral Hadoop and Spark clusters in general. And we give you a lot of tight integration back to the rest of Google Cloud. So we are not just giving you yet another cluster that you're going to have to go manage. We are letting you run all of your existing open source software, but still modernizing your stack as we do this. And we give our Cloud Dataproc customers a lot of flexibility in how they choose to run the Dataproc service. So we expose a lot of knobs. Now, we try to put sane defaults on those knobs, so if you don't want to deal with that, you can just go and get started very easily. But those knobs are exposed, and so we have customers that use Dataproc in a couple different models. The first model is this idea of a job-scoped cluster. And this is really effective for our Cloud Dataproc customers with batch or ETL type jobs. Now in this mode, you can have a single command that will send a graph of jobs to Cloud Dataproc. We will spin up a right-sized cluster, run those jobs, make sure that cluster gets torn down, and then save all of that information about what happened, all the logging and audits, into StackDriver for you. And this works really well with Cloud Dataproc because we can usually give you a fully loaded Hadoop and Spark cluster in around 90 seconds. So when you only have a minute-and-a-half overhead to creating a cluster, you can start to think about jobs and clusters almost as this single entity. And we have a lot of features that are going to help you with this model, things like our Jobs API, workflow templates, and clustered schedule deletion. But we also have customers that tell us they have scenarios for long-running Cloud Dataproc clusters. And these might be scenarios for things like, if there's a shared interactive analysis with Jupyter or Zeppelin notebooks, or maybe they're building BI applications based on Druid. And we have plenty of features like our high availability mode and our Autoscaler that are going to help with this model too. And if you want to learn more, Mikayla and I actually did a top 10 tips article on the Google Data Analytics blog a couple months back you can find. And she even has a webinar associated with that. So there's a lot of materials out there if you want to know more about how to run long-standing Cloud Dataproc clusters. But regardless of the model that you choose, our goal with Cloud Dataproc is changing open source software to be cloud native. This means making features that are going to be fast, easy, and cost-effective. Last year alone, we put more than 30 new features into Cloud Dataproc. And so this is still an area Google is heavily investing in. And so now let's jump in and actually start talking about some of these new features and what's going on in Cloud Dataproc. So I'm going to start by talking about some of the recent open source software we've recently integrated with Cloud Dataproc. Now the theme to all these features that I'm about to talk about is that Cloud Dataproc lets you take the open source tools, algorithms, and programming languages that you're already using today, but make it really easy to apply them to cloud-scaled data sets, while at the same time helping you integrate with the entire GCP ecosystem. We just recently launched a new version of Cloud Dataproc. It's now generally available, version 1.4. The headliner on this version is probably Spark 2.4, and that comes with a lot of usability and stability updates. And that's something that you can really start to combine with Cloud Dataproc. We also had a lot of customers that told us, hey, we love Cloud Dataproc, but we've built so much of our enterprise tooling and internal standards around Ubuntu. So we went back and we recreated Dataproc on Ubuntu. And that exposed a new knob, a choice of image or operating system type for Dataproc. Now, for years, we've had customers that have built very tight and sophisticated security controls with Cloud IAM and VM and cluster isolation. But we've also had customers that wanted the open source tools like Kerberos built directly into Dataproc, which is why we now have a beta version of Kerberos integrated with Dataproc. And this is going to let you do things like tie back your Dataproc users to Active Directory, or it makes it a simple button click to turn on Hadoop secure mode, or add encryption in flight. Tomorrow at 9 a.m., I'm going to be speaking with Cloudera on securing your data lakes. And essentially, we're going to have this a 55-minute presentation on this entire slide. So if you are interested in what's going on in Hadoop security, I'd recommend that session tomorrow morning. But back to Dataproc itself, when you create a Dataproc cluster, you can specify what we call an initialization action. That's an executable or script that Cloud Dataproc is going to run on all nodes of your cluster immediately after that cluster spins up. Now, we talk to a lot of our customers, and we ask them, we try to identify the most common open source software that's being installed on Cloud Dataproc. And then what we want to do is we try to provide starter scripts, so everyone's not rewriting that same code. And those are the initialization actions that we put into our GitHub repository. Some of the more recent initialization actions include Apache Ranger. And we find a lot of customers, when they start with Cloud Dataproc, they might be starting with a pretty monolithic on-prem cluster that's sharing resources between ad hoc BI analysts who are trying to run their SQL queries and waiting for those queries to come back, along with a lot of scheduled and batch jobs that have piled up over the last couple years. And so one of the first ways that customers start to migrate to the cloud is they take a lot of those batch and scheduled jobs and start putting them into Cloud Dataproc to free up that on-prem cluster for the analyst. And we've had customers that said, hey, the code, it maps over great, everything runs, but I would really love to keep all of my existing security controls and policies without redeveloping all of that. And so that's where something like the Apache Ranger initialization action can really help get them started doing that. We've also recently created an initialization action for HBase. And while we do at Google Cloud have Bigtable, which is a NoSQL store with HBase API compatibility, customers, they've told us, hey, sometimes I just need coprocessors, or I want to run Apache Phoenix with SQL. And so that's why we came out with Apache HBase. We also have the fish that you see there. That stands for Tony, or TensorFlow on Yarn. And that's a project that we did with LinkedIn that makes it easy to run TensorFlow jobs on your Dataproc cluster without having to move over to a separate API like CMLE. You can just call it directly from your Spark workflows and have TensorFlow scale. And there's actually a full next session tomorrow at 11:40 that you might want to check out if you want to learn more about that one. But again, the theme here, you're probably sitting here staring at all of these open source logos, and you might be thinking, hey, doesn't Google have a fully managed offering for some of this stuff? And you're right, oftentimes they do. But Cloud Dataproc, our goal is just to make it easy to run that open source version of the software, if that's your preference. Now, we've also recently had some optional components that got promoted to either GA or beta. And an optional component, that's what happens when initialization actions, it reaches enough popularity that we decide we're going to make this a first-class Dataproc citizen. An optional component, that's software that you can just add with a simple checkbox, and that becomes part of the Dataproc image. And so that gives you the fast cluster spin-up time, but it also gets you fully integrated with all of Dataproc. And if you want to know what I mean by fully integrated, that's something go talk to your cluster admin about. They probably know what it's like to try to keep up with all of the latest versions of this various open source software and keep everything in sync. You install the latest version of Spark. It's, a butterfly flaps its wings. It steps on some Java dependency over in Zeppelin, and now all of a sudden all your class paths are misaligned. Like, that's the kind of things that, because we bake, the optional components into the image itself, that ensures that this whole menagerie of open source software is actually working in tandem. And a new optional component we just put into alpha is Druid, a column-oriented open source distributed data store. You'll most often find this with OLAP applications on really high volume data. So one common use case that I keep seeing with GCP customers is they're taking something like an Apache, Kafka, or a Confluent incoming stream. They land all of that data into a Google Cloud Storage sink. And then folks want to see dashboards on that data about what's coming in real time. And they might want that daily, they might want that hourly. And so they can schedule a Cloud Dataproc cluster to spin up, run those aggregations, upsert that into a long-running Cloud Dataproc cluster running Druid, and then tear down that cluster that was running those jobs. And then you have your applications for the dashboarding or whatever going against that OLAP Cloud Dataproc store running Druid. The Dataproc Jobs API, we have a new Spark R job type available for that. Now, the Dataproc Jobs API, that's what makes it possible to submit a job to an existing Cloud Dataproc cluster with jobs.submit call over HTTP, or if you're on a command line interface, you can use gcloud, or even in the Google Cloud Platform console itself. And so now it's possible to submit your Spark R jobs through that Jobs API, which has them logged and monitored, and that makes it really easy to build automated tooling around your R code. It also makes it pretty easy to start separating the permissions of who has access to the cluster versus who has access just to submit jobs against the cluster. And you can do that now without setting up gateway nodes or something like Livy. You can just use the Jobs API. And a new feature that just came out is this component gateway. And you see what it does here is I can now, with one button click, enable the component gateway, come into the web interfaces, and it will expose the web UIs associated with the components that are running on the cluster. And I can click into those based on my Cloud IAM permissions. And again, this is a new feature along the same lines of the Jobs API, where we want to make it easy to access Dataproc without a bunch of sophisticated edge nodes or networking setup. We want to make it easy that you can use GCP as your security perimeter for some of the more common scenarios. So Component Gateway, it was built on top of Apache Knox, and it reverse proxies and exposes the web UIs. And then as long as you have the proper Cloud IAM permissions, you can directly access them. So a lot of clouds, when they build their connectors, they will keep them internal. So you have to be using their services to take advantage of the first-class connector. And the open source community, they've done a great job of responding to that, and they started building their own connectors. But what we saw is that created both a lot of friction in the community, as well as confusion from customers about, hey, what connection should I really be using? So at Google, we decided to take a different approach. all of the connectors that we build from Hadoop into the Google Cloud Platform, those are fully open source. So we chose to work with the open source community instead of against them. And our connectors, they're also built with these cross-team collaborations at Google. So our Google Cloud Storage connector, that is something that we did hand in hand with the Cloud Storage team to make sure that you're getting the optimal performance out of these connectors. So to tell you more about some of the new and improved connectors that are available, I'm going to bring up Karthik, who's actually one of the engineers on that team.
So Dataproc is really the bridge, like we see it as the bridge between the Hadoop world and Google Cloud. So to kind of be clear on what connectors means, the idea is that you can still store your data in services like BigQuery or Google Cloud Storage that can be used through other cloud platform tools, but at the same time process your data through tools that you're already familiar with in your kind of Hadoop ecosystem. So the first, I'm going to go through a few new connectors, and this is like the first one. I think this is really the coolest. It's a set of new BigQuery Read connectors. So the old BigQuery connectors, the way it worked is it would export data from BigQuery into GCS, and then your job would read the data from GCS. What that meant is that your cluster actually sat idle for maybe up to minutes as that data was being exported. But through this new BigQuery storage API, we can actually stream data directly from BigQuery. And BigQuery actually intelligently, dynamically rebalances between map tasks so that you don't end up with key skew and the tasks actually finish at about the same time. And we can also push down predicate filters and column filters into BigQuery, so that way you reduce the amount of data that's actually read out. And finally, the last major improvement there is you look at Spark in particular. That's why I put it up on the slide. In the old connector, you kind of have to use the MapReduce API, which is very difficult to work with. But now we integrate with the Spark data source API. So now it's just spark.read.bigquery, give it a table name, and you have a type data frame that's correct that you can use in your Spark jobs. There's also a connector for MapReduce as well. So kind of similar, there's another connector as well for Cloud Spanner. It is also open source on GitHub. Actually, all three of them I'm going to talk about are on GitHub. And this one is still under active development, but kind of the same concept here. We push down filters, and it integrates with the Spark data source API. So it's just spark.read.format Cloud Spanner, and again, you have a correctly typed data frame to work with. And finally, I'll run through some quick improvements in the GCS connector. There's been a lot of work in the GCS connector in the past year, especially around performance. So the first big one is really around supporting columnar file formats. So the idea is with these columnar file formats, you might have a footer at the end of the file. And so if you're filtering data, you might be able to skip the entire file or just read a small section of it. So we really improved random access patterns in the GCS connector, and that's what really makes it up to 4 times faster for certain Parquet workloads. And the other major improvement was around multi-threaded batch requests. So if you're renaming a large directory or deleting a large directory, that is now significantly faster. And so again, just to kind of reiterate, the big thing here is we're really focused on being good open source citizens. Instead of proprietary connectors, these are all open source on GitHub, and the community can also contribute to them. And with that, I'll hand it off to Mikayla to talk about auto awesomeness.
All right, so what is auto awesomeness? So auto awesomeness basically means that we manage your infrastructure for you so that you can just focus on the insights. And we have a whole host of different auto awesome features that help you do this. So we have lots of features that help you manage clusters. So for example, one is scheduled deletion. So let's say I have a cluster and I want to say, okay, if this cluster is idle for more than 10 minutes, I want Dataproc to just automatically delete it for you. So you can set that up. And then we manage your jobs too. So we have the jobs API. We have 8 different job types now so that it's easy to submit jobs through whatever automation that you're using. And then we also have ways to manage clusters and jobs together. So on the next slide, I'm going to talk about workflow templates. So what is a workflow template? What is a workflow? So a workflow template is a way to specify a graph of jobs that you want to run, so any arbitrary job dependencies, alongside the configuration for the cluster that you want those jobs to run on. So when you run a workflow, what happens is Dataproc will spin up a cluster on your behalf, run the graph of jobs on that cluster, and then tear down the cluster. And even if something goes wrong in the workflow, we'll clean up the cluster for you so that you don't have to worry about it. You can do all of this with a single API call, which is really powerful. So you can actually run a workflow right directly from the UI. And then you can monitor the progress of this workflow as well. So you can see the jobs in this workflow. This is just a simple like TerraGen, TerraSort, TerraValidate. The TerraGen job is done, the TerraSort job is running, and the TerraValidate job is waiting for the TerraSort job to finish. So another auto-awesome feature that we have for managing your jobs that's coming soon is the ability to see all the logs associated with a particular job in StackDriver Logging all in one place. So you can select a particular job by job ID in just a drop-down, and then you automatically see all the driver logs and all the container logs all in one place here in StackDriver. And StackDriver is not just used for logging, it's also used for monitoring. So we have full integration with StackDriver monitoring as well. So we export metrics from your cluster to StackDriver monitoring, and that's actually how our Autoscaler makes decisions about how to scale. So to talk to you more about Autoscaling, I'm going to hand it back to Karthik real quick.
Yeah, so I really see autoscaling as the premier auto-awesome feature. Because autoscaling is kind of really the story of cloud, the idea that you just pay for the resources that you use. So with autoscaling, jobs are fire and forget, and then autoscaling can scale up and down clusters to match your workload. So we still want to give you low-level control into how autoscaling works. So importantly, you can set the minimum cluster size and the maximum cluster size, and you can also control how aggressive the autoscaler responds to Yarn metrics. So just to kind of dig in, Dataproc runs Yarn. It's called yet another resource negotiator, and it's kind of the scheduler for Hadoop. And all Hadoop jobs run on top of Yarn. So if you take a MapReduce job, for example, a MapReduce job gets split into a set of map tasks and a set of reduce tasks, which are then queued in Yarn to be scheduled on the cluster. If there's a lot of work pending in the queue, then we should scale the cluster up. But if there's a lot of free space left in the cluster, then we shouldn't scale it down because we have too much capacity. So we allow you to choose how to respond to these Yarn metrics and how aggressively. So for example, something neat you can do is if you have very high priority jobs, you can actually set it so the cluster just scales up when you submit a lot of jobs, but only scales down when the cluster is idle to avoid interrupting any jobs that are in progress. So last year we launched autoscaling to alpha. This year we're launching it to beta, and there have been a whole slew of improvements, and I'll go through a few here. So first, we've enhanced the fine-grained controls that you have over autoscaling. So for example, now you can update autoscaling policies at any time, and you can also stop autoscaling on clusters. This is especially important for long-running clusters, where you might need to tune the autoscaler over time. We've also focused a lot on usability. So you might have noticed in the cluster page that you now have a dashboard of Yarn and HDFS metrics. And this really helps understand why the autoscaler is scaling up or down, based on the utilization in your cluster. And we've also put the autoscaling decision history in StackDriver Logging as well. And finally, we focused on job stability, the ability to scale up and down MapReduce and Spark jobs without having them fail. And we'll touch on that more a little bit later, so I'm just giving you a little teaser. So I'll switch gears here and talk about preemptable VMs. So preemptable VMs are kind of a really neat concept in Google Cloud. They're instances that are up to 80% cheaper, but can be preempted, which really means that they're kind of taken away. They're shut down at any time if GCE needs to sell that capacity elsewhere. So a lot of workloads are okay with nodes joining and leaving, and that means that this 80% cheaper VMs can actually make it way more cost effective. So you think that the Hadoop ecosystem is built around this idea of nodes coming and leaving. So you add a bunch of preemptable VMs to your cluster, but then your jobs start actually failing. So Mikayla will talk a little bit more about why this is.
All right. So you added a whole bunch of preemptable VMs to your cluster and your job started failing. So what's going on? So let's do a brief refresher on the anatomy of a MapReduce job to kind of understand what's happening here. So in MapReduce, you got your mappers and you got your reducers. So you have your map tasks running on those nodes, and then your reduce tasks need to fetch data from your mappers. So they fetch the output of the map tasks from those nodes. And so your job is going along, it's like almost done, but then one of your mappers gets preempted. And as a result of this, all those reducers that were fetching data from that mapper, those reduced tasks also fail. So now, not only do you have to rerun this map task, you also have to rerun all those reduced tasks that were fetching data from that mapper. So that's kind of unfortunate. So we've actually launched a feature to alpha that helps mitigate this issue. Can you switch over to the demo stream? All right. So this feature is called Enhanced Flexibility Mode, and we have it for both MapReduce and Spark. So Karthik, can you start that video? So first, we're going to show you an example of what happens when you don't have Enhanced Flexibility Mode enabled. So here, I'm submitting a job to a cluster, and this is just like a tiny, like 10 gigabyte shuffle. And this cluster does not have Enhanced Flexibility Mode enabled. So what we're going to do is, once this job gets going, I'm going to remove the preemptable workers from this cluster, and we're going to see what happens to the job progress, and it's not good. So just waiting for this to get started. And then after this, we'll show you what happens when Enhanced Flexibility Mode is enabled, which is very exciting. All right. So we're going to switch over to the cluster tab here. We're editing this cluster. It used to have 5 preemptable workers, and we're reducing that to 0. So now we're scaling this cluster down, getting rid of those instances, and let's monitor our job progress to see what happens. I know that's kind of hard to see, but it looks like we're at like 71%. We're like chugging along. If we go back over to the cluster tab and look at those instances, we see those VMs are now getting removed. All right, so let's check back in on the job, and all right, it went down from 75% to 21%. So all that progress was lost. You have to rerun those tasks, which is pretty unfortunate. So Karthik, can you switch to the next video? So now we're going to talk about what happens. This is the exact same setup, but this cluster has Enhanced Flexibility Mode enabled. So same setup, like 5 preemptables, like 2 normal workers, submitting the same job, like a 10 gigabyte shuffle. Yep. And then, so with Enhanced Flexibility Mode, we actually write the output of those map tasks to a distributed file system so that it's checkpointed and you don't lose that progress. So once a map task has finished, it'll never have to be rerun again for any reason. So we'll watch the job progress for this one and see what happens. So we'll wait for the job to get going and then scale down the cluster again. And now it's important to point out that in-flight map tasks will still be killed, so you will still see some progress lost. But all the map tasks that are already done, that progress is saved. All right, so we're switching over to the cluster tab. We're going to edit the configuration to only have 0 preemptable workers. And then again, we'll watch what happens with that job. All right, so it looks like we're at, I can barely read that, 58%. And we can go see those VMs. Yep, all right, the VMs are going away now. So we can check back in on our job. All right, so this time, the progress went from 58% to 45%. So that's like way less dramatic than what it was before. And the other one where it went from like 75 to 21 or something like that. And then also keep in mind, this is like a tiny 10 gigabyte job here. So for larger jobs, the like percentage of the total job of progress that is lost is a lot smaller. Yeah, so with this feature, this is also, it works well with scaling. So I guess if you wanted to see no job progress lost at all, you can actually use graceful decommissioning. So with graceful decommissioning, we wait for the containers to finish on the nodes before we remove the nodes. And usually, so with enhanced flexibility mode, this is a little bit different than how Yarn graceful decommissioning normally works. So with enhanced flexibility mode, as soon as those containers are done, so as soon as those tasks are done on those nodes, we can remove the nodes right away, even if the application isn't done yet. So this is different than how Yarn graceful decommission normally works, because normally those nodes have to sit around for the entire duration of the application because they're still serving shuffle data. But now they're not. Now that shuffle data is in a distributed file system, so we can remove those nodes sooner, and so now scaling can be more responsive. I'll hand it over to Chris, I think. We can switch back to the questions slide. Could we switch back to... Oh.
Do you want to advance one slide?
Can you advance the slide? Oh, whoops. Okay, I guess I can.
Okay. So yeah, that's the end of the session, everybody. We did try to save some time for Q&A because there's probably a lot of questions about these features, and we're happy to speak with those. So to speak to those, so if you want to just, anyone that wants to come to the mic, we're happy to answer questions.
Excuse me. Did you have a chance to benchmark the performance impact of spilling all of the shuffle data to disk? Or, I mean, to sounds like GCS?
Yeah, so we did some benchmarking. So we benchmarked against HDFS and GCS as well. So for like small to mid-sized shuffles, it actually looked all right. For bigger shuffles, that's something that we're actually working on actively, like this quarter, to improve it. So this is kind of like an alpha launch, and we wanted to get it out there for users to like start experimenting with. So we're kind of like actively seeking feedback for, I guess, people who are using this feature.
Awesome, thanks.
Yeah.
Hello. So I have a question about the autoscaling. Am I correct that this autoscaling is mostly the horizontal? It's not a vertical?
Yes, that's correct. It's only horizontal scaling.
Any plans?
It's something we've thought about. But at the moment, no. I mean, if you want to talk about your use case, I'd definitely be, like, come and find me afterwards.
Okay.
I'm curious why you're interested in it.
This Autoscaler is very cool. Do you basically have your own, like for Spark, for example, do you have your own fork of Spark to be able to do such a thing?
So for the enhanced flexibility part, sort of yes. And this is stuff that we plan to open source, actually. We, as we said earlier, we were trying to be good open source citizens here. So Ben actually is the person that did Spark enhanced flexibility, and Mikayla did MapReduce.
And does that rely on Yarn? I guess
So Spark already schedules its executors on Yarn. It's like Spark on Yarn is already in the Spark project.
I'm thinking, like in the future, that would be pretty awesome if we can take advantage of this feature, for example, in the Kubernetes world, and have the shuffle files being stored in GCS, I guess, is where I'm going with that.
Were you saying, sorry, in what world?
In Kubernetes.
Kubernetes, yes.
So yeah, because this is also a problem that Kubernetes is trying to address actively as well.
Okay,
so,
this is awesome.
Yes, definitely all stuff we're thinking about.
Hi. So my question is more on like, let's say there's an optional component that I installed, and you showed that you have support for Flink 1.6, but right now Flink is at 1.8, and there's some features I want. How easy is it to upgrade it? Is there a way to apply a patch, or we have to set up our own Flink cluster across the cluster ourselves, or is there a way of easily upgrading it?
So if you're purely looking for like a particular patch, like a bug fix, it's pretty easy. Like reach out to Dataproc feedback, or I can talk to you afterwards. We do patches. If you're talking about version upgrades of Flink, that we do as well. I mean, we do try to stay pretty up to date, especially in Spark. But as people request newer versions, we'll add them.
We do our best to keep up with the community, and we really respond as much as we can to customers that are pushing for the latest and greatest. But you do have full control of the virtual machines. So if you wanted to upgrade that, whatever is on the operating system, you do have root access to it and can do what you want.
Right. And second question is that Spark has a lot of its own optimizations, such as adaptive execution mode and cost-based optimization. In your fork, are you kind of letting Spark do all its work that it does, or are you overtaking some of the things that Spark does to have this enhanced flexibility or checkpointing or those kind of things?
Sorry, could you say it one more time? Are we?
There's a lot of things.
Do you override Spark's native features to have your own, or are you
No,
allowing
I
Spark
mean-
to do scheduling in fair mode?
Yeah,
and
all of that is the same. Yeah.
Okay.
So.
Yeah,
So if it wasn't clear through the presentation, like enhanced flexibility right now is purely around shuffle. So that's like cache data, for example, is not yet enhancedly flexible.
My question is more around, like, let's say there's skew in your data, and then Spark kind of recognizes that and dynamically repartitions it. So you're not touching any of that?
No.
Okay.
It's like, if you turn on like cost-based optimization in like 2.3, then that should all still work.
Okay, cool, thank you.
Yeah, and then when there are kind of overlaps with this, like for instance, Mikayla brought up graceful decommissioning, that is something that we're trying to change in the open source Spark and push upstream. So when we do hit the overlaps, we are trying to work with the community on it.
My question is, I wanted to ask you about graceful decommissioning. Is it not fulfilling the purpose that you have presented already? Is it not? When you configure graceful decommissioning, is it not like waiting until the map job is done before?
So it does. So right now, if you have enhanced flexibility mode enabled, so we actually made some changes to graceful decommissioning so that it works better with enhanced flexibility mode. So it waits for those map tasks to be done before decommissioning those nodes. So when I was showing in the demo, I actually didn't use graceful decommissioning, and that's why we saw some progress lost even with enhanced flexibility mode on, because we didn't wait for those in-flight containers to finish. But with graceful decommissioning, we wait for the containers to finish, but we don't wait for the entire application to finish, because now we don't need to, because the shuffle data is like preserved. The nodes don't have to serve it.
Okay.
Did that answer the question? Or
Yes, I will have a look, thank you.
Okay.
I also wanted to say you that I have tried the H-base initialization action. It works really well.
Oh, good.
And I think that is also really well documented. I just wanted to say, I think that maybe adding a drop-down menu just below the initialization action, where you can quickly choose the H-base or Ranger or whatever you like, might be a little more appealing than having to pull from cloud storage and like create a.
Oh yeah.
But
I totally agree. So there's
suggestion.
there's stuff
we're,
in the works.
That's
for that.
excellent feedback, and we are on it.
Yeah.
Thank you, guys.
Hopefully by the next that will be there.
Yeah.
First question is there any plan to expand the pre-built image list? Right now, like, if you look at the options, it's like, comparing to, a general, execution machine, you have like a long list of options. But if you go Dataproc, it's maybe like 5, 6, different options of pre-built image. Is there any plan to support
we try to address this. I think there's more than 5 or 6, but like we do try to address this with custom images, where you do have the capability to come in, put whatever you would like on the image. Oftentimes, enterprises with strict security controls will put their own security constraints on it, or you might have some additional versions that you want to upgrade independently. Right. You have the ability to do that, and then you can create a custom image and then come back and use that image. So we do give you the flexibility to do what you need to do with the image.
So like even without any customization, say like do we have any plan to support like CentOS and different kind of operating system?
So we just added Ubuntu because we got
I saw that, yes.
just based on customer demand. So if you do have use cases for that, I'd love to talk to you about it and see if it makes sense to do additional images, because that's where Ubuntu came from. Is just customers were asking for it.
Okay.
And as well, like a little bit more background. Ubuntu is also very straightforward because it's the same packages between Debian and Ubuntu. So that's another reason that CentOS is like potentially more difficult to.
Okay. Do. Yeah, that's we are looking for CentOS support. Okay. And
cool.
The next question is what's the difference between the templates and Composer? Is there any like a feature function overlap?
Yeah. There's actually, before I'll let them talk more, but there actually is an integration point between them. So Cloud Composer does have a workflow templates operator, so you can drop into Composer, that's operator, and that will do all of your Dataproc jobs and cluster all as one black box entity within Composer. So there is an integration point, and that's how customers typically work together with them. I don't know if you want to add more to that.
Yeah, I mean, I was basically just going to say the same thing. Like a workflow, a Dataproc workflow can be like one node in a Composer, like a bigger Composer orchestration.
Yeah.
So like, I mean, Composer is integrated with like all sorts of different things in GCP. Workflow templates are kind of our like Dataproc native workflows. So you could do the same thing in Composer, but it's kind of annoying in Composer to have to be like, okay, let me create a cluster and then submit these jobs and then tear down the cluster, like all these nodes in the graph where logically it's just like one operation. So like Dataproc does this part of my overall pipeline.
So, so then I have another 2 questions then.
Yeah, sure.
Is there any like, say like, I don't want to have 2 different templates over there. One is built on top of Airflow, the other is built on top of the templates. Is there any way I can like use the same templates in Airflow? I mean, in Composer.
Yeah, so I mean, there's a workflow operator, like a Dataproc workflow operator in Airflow. So you can use your same workflow templates from Dataproc in Composer.
Okay.
Yeah,
So
and one of the things to consider is that Dataproc workflows are really just a convenient way of saying I want to run these jobs in this cluster, but there's no actual native scheduling. So
Right.
if you want to say like run this job twice a day or like when data arrives in
but
GCS,
still you have like, some overlapped function, between templates and the Composer, right?
yep.
That's the only if like these 2 are total exchangeable and compatible, I might take the approach. Otherwise, I will stay with
Yeah,
Composer,
it just
right?
comes kind of down to our general theory about like we try to expose a lot of knobs, and so you want to turn the more detailed knobs, you can do that directly in Composer. You want to abstract that all away and treat it as one black box, workflow template box. You can do that, and that way you might even have, depending on what organization you're in, like there might be somebody that does the Dataproc workflow templates, and then they can hand off that entire black box to the person doing, Cloud Composer, Airflow workflow. So it's just sort of where do you want to turn those knobs?
I definitely see the value of the templates here, but I just don't want to have 2 different versions of templates, one running in Dataproc kind of templates and the Composer
Sure.
kind of.
And like feel free to come talk to us later about like your use cases as well.
Thank you.
Hi, for the Spark BigQuery connector, like it's not like you guys removed the intermediate like storage when you're reading, but did you also remove that for writing as well, or just writing is still writes to the?
So right now this is just the read connector. So there's not a similar write connector yet.
And you notice like the other thing is like the write connector is like whenever like it's a 2-step process, right? So yes, you write it to GCS and then GCS loads into BigQuery, but sometimes the load fails, but your connector doesn't retry. Like we have to see it. I mean, is there a way for you to retry because it's part of your connector, right? So
Yeah, that is a lot of the libraries have low-level retries, but yeah, that's something to look into. Like again, our connector is on GitHub, so if you file an issue there, we'll also take a look. So, yeah.
thanks.
Hi. So this is more of a follow-up question on the graceful decommissioning and the flexible
Yeah, sure.
scheduling. So if graceful decommissioning will wait until the completion of the task regardless, right? So in the original version, when you saw that 50% drop, if you had graceful decommissioning, would you have seen any drop at all?
So we wouldn't have, but it's kind of a pain because the nodes wouldn't be removed from the cluster until the application is completely done. So I guess a big benefit of the enhanced flexibility mode is you can remove nodes from your cluster faster, so you're not paying for them when all they're doing is like serving shuffle data.
Okay. Is there like
and it's also
a breakdown on like? Sorry, I was considering like if that's the main benefit, right, of this new feature in the sense that you can tear down faster. Do you have any kind of numbers on what the distribution, what the benefit is of like a job to its shuffle time and to the cost?
So I don't have exact numbers on me right
just
now.
General idea.
But I guess again for like small or medium-sized shuffles, like the times of the jobs are like comparable, I guess. And then for larger shuffles, sometimes, especially if you're using HDFS, there can be some bottlenecking issues with the name node, and you can tune the name node to avoid those. If you use GCS, you don't see those issues as much. But
yeah, and essentially this is why we decided to make this feature a public alpha versus a EAP or a private alpha, because we want as many people testing it as possible so we can start to do these benchmarks and figure out best practices. And that way when we do hit EA, which is, hey, we really trust this, that's going to become coupled with, and here's the type of cost savings you can expect, or here's the kind of trade-offs you can expect with these different settings. And so we do plan to get more crisp on a lot of that stuff.
Yeah.
But right now it's just about getting it out there, getting folks using it, and starting to test out a lot of this stuff.
And then again, I mean, another one of the huge reasons we did this feature is to help you with cost savings. So I guess if you want to use a lot of preemptible VMs, so I guess in the demo I showed me purposely removing the preemptible VMs, but you don't know when the preemptible VMs are going to go away. So when the preemptible VMs get preempted, there's no graceful decommissioning there, I guess. So I guess that's why I demoed what I did
So if
to show.
a preemptible gets preempted, it
Yeah.
still doesn't gracefully decommission.
It does not. No.
Okay.
Yeah. So it's to help
All
with
right,
that.
That makes sense.
Yeah.
I have one quick one afterwards.
Yeah, sure.
Basically, for the autoscaling, I noticed it's in beta. Do you guys have an idea or a timeline for when it would be in GA?
Not a firm timeline, but the idea is in the next quarter or two.
Yeah, very soon.
Okay, cool. Thank you.
All right. Well, cool. Thanks for coming.
Thank you everybody for sticking around. Appreciate it.